नमस्कार दोस्तों, स्वागत है आप सभी का एक बार फिर इस नए वीडियो में। एंड इन दिस वीडियो वी आर गोइंग टू डिस्कस अबाउट द रिलेशन between linear velocity and angular velocity. Okay, so first of all we have to understand what is this linear velocity and angular velocity. Okay, linear velocity means it depends upon the motion. Okay, and which kind of motion is there, in which particle is moving, and that decide what kind of the velocity there will be. Okay, it will be linear velocity or either it will be angular velocity. Okay, angular velocity. Angular motion means when a point is moving, कोई आपका object है that is moving around a fixed point or fixed axis. Okay, that kind of motion is called angular motion, and the velocity associated with that kind of motion, that is called angular velocity. Okay, and linear velocity, as you all know, linear velocity, what does it mean? Linear velocity means the velocity of a particle, okay, which is in the linear motion, okay, which is like a straight line and whatever it will be. Okay, in this video we are going to discuss and to derive the relation between angular velocity and a linear velocity. Okay, linear velocity. So let's assume that a particle is moving, okay, in a circular motion. Okay, let's see here, and remember, always you have to draw a suitable diagram for the question. Okay, whatever it will be. So this is your particle, sorry, this is not perfect circle. Okay, it will be perfect circle. Okay, this is the particle motion. Okay, this is the path in which the particle is moving. Okay, let's understand that this is moving with the linear velocity v. Okay, and this is the point. Okay, this is, let it is the center point O. Okay, and this is the distance from O to P. P is a point here. Okay, and let a point start from moving P to Q. Okay, here, and this is the axis. Okay, this is the axis. So your angular velocity will be this. Angular velocity means when your particle is moving under angular motion. Okay, and when that particle is under angular motion, there will be angular velocity. Okay, so that is W, and angular motion is what? When a particle is moving around a particular fixed point or axis. Okay, so this is your angular velocity. So let's, our particle is moving from P to, this point is Q. Okay, P to Q, and this travel a distance, what? Let this is delta S. Okay, and the angle here, okay, that is angular displacement, and that angle is delta theta. Okay, so let's understand this thing. What is delta theta? Is equal to delta S over R. R is the distance between O and P. Okay, so this is the distance between O and P. So here we will apply by a trigonometry theorem, because this angle is very small. Okay, so because of this, angular displacement is equal to linear displacement over the distance between O and P. Okay, now dividing both side, by delta t. Okay, when we are going to divide this equation, okay, by delta t, so we will comes out with delta t is equal to 1 over r delta s over delta t. Okay, now we will take the limit. Okay, taking the limit, so what is the equation in previous page? That is delta theta over delta t is equal to 1 over r delta s over delta t. Now taking the limit, Now taking the limit, okay, now we are going to take the limit delta t tends to 0. Okay, so both side we are going to do this. Okay, so here we will comes out with a limit delta t tends to 0 delta theta over delta t is equal to 1 over r limit delta t tends to 0 and delta s over delta t. Here this limit delta t tends to 0 delta theta over delta t is called what? D theta over dt equal to omega, means instantaneous angular velocity. So this is equal to angular velocity, and this limit delta t tends to 0 and delta s over delta t, this is equal to what? This is equal to instantaneous linear velocity. Okay, so this will comes out ds over dt is equal to v. We already know this thing. What is velocity? Velocity means the rate of change of the distance. Okay, distance is s and what is the time is delta t. Okay, so this will be equal to linear velocity v. So here is omega. So actual relation between the angular velocity and linear velocity will be equal to omega, this omega, and 1 over r v. Okay, what is this r? R is the distance between the radius of that circle, that is made by the motion of that particle. Here O and P, distance between O and P is r. Okay, so from here we get the relation r omega equal to v. So this is the final relation between the angular velocity and linear velocity. Here the linear velocity is v equal to omega is the angular velocity and r is the distance between O and P, means the radius of that particular circle, okay, in which that particle is moving. Okay, so this is the final relation between the angular velocity and linear velocity. I hope you like this video. If you like our video, then do give a thumbs up. Okay, thank you so much.